Hello and welcome to all students of computer science, automation, and electronics. Tonight we are considering networks, and it would be true to say that networking is responsible for the entire change of our planet within the last few years. Now, if you look, you'll see that we have some network topologies here. Topology relates to how your computers or nodes are connected together. The little squares shown in the diagram, each little square could be thought of either as a computer or as a microcontroller in automation or as a microprocessor-based dedicated subsystem or as an FPGA, or even as a PLC. It's a little autonomous gadget that does something within the context of your automobile, factory, or even your office in a computer network environment within the businesses. So, this is the way that they can be interconnected together. Now, each method of connecting them together is going to have certain advantages and disadvantages. Let's start with the star. What are the advantages of the star? Well, each node has a dedicated connection to the master, so it's a centralized system. It's very simple to add additional nodes or computers. It's easy to implement with fiber optic cables, but it has some disadvantages. Some of the cables could possibly have to run long distances, and there's definitely a lot more cable in that arrangement than in many of the other systems. So you're going to use lots of cable. Central node will have a connection interface for every single node, which will mean that the central node will be fairly complicated. The communication between the nodes would only be possible, they would all have to go through the master, so the master would control all communications within the system, and this is its biggest weakness. The whole system will fail if that central node goes down. How about the ring? Well, in the ring system, every single node in the ring regenerates the signal or acts as a repeater. So extending the network over a greater area is quite possible. We can have a gigantic ring, and the more nodes we add, the bigger the perimeter of the ring can become. Point-to-point connection is perfect for optical media because each node is connected to every other node by only one point-to-point connection. And because it's arranged in such a way, order, there's very easy to find the identification of any particular node in the ring, so we don't have to have complex addressing schemes to address the individual nodes. The disadvantages of the ring are that, just like the star, if one node fails, the whole ring goes down. And you have to shut down the entire ring to add, remove, or repair individual nodes. What about the tree? Well, the tree begins to approximate a model of a graph, a mathematical model of a graph. And if the tree is properly designed, you can minimize cabling and installation costs and adapt it to whatever geographical requirements you need. You can also add nodes without shutting down the whole system in most cases. And because it's still using point-to-point, it's still great to use with optical media. The disadvantages of the tree are that we now have a much more complex node identification scheme to be able to communicate, like a node in the tree trying to communicate with another node may have a large number or very long address to be able to find another leaf or node to talk to. Failure of certain nodes can still bring down others, because in the tree hierarchy, you could get a node that a branch, for example, would bring down a lot of leaves. So you can get a problem with that. Now, what about the bus? Well, the bus, which is actually the most popular of all, still has some disadvantages. The advantages of the bus, that it's really simple to add, remove, or repair nodes without affecting the network in any way. And we can set up any kind of logical communication structure so that there's no limitation on how the nodes may interact communication-wise, talking to each other. We can design it any way we like, but there is no physical imposition of a specific communication strategy. Now, what about the disadvantages? Well, we need repeaters to extend the bus length. And the bus length is tied directly to the termination requirements. So there's a relationship there between the length of the bus and the termination type that needs to be used to avoid reflections on the bus. So we can't just add as many nodes as we like, and it becomes a little more complicated to extend the bus over great lengths. So that is why we're saying that we can use repeaters to connect buses together, which is only a disadvantage because it adds complexity and increases cost. Finally, the bus system of all the systems is the most expensive and difficult to use when trying to use optical media like fiber optics. It leads to very complicated systems, and they are more expensive. So if you're having a fiber optic system, it's not that it can't be done, it's just a little more difficult to do. Finally, we get to radio networks. Now, the radio network as a network has clear advantages over wired networks because you can use your radio network over widely separated geographical areas out in deserts and oil fields and, even across continents. Once we're going to the radio mechanism, we have no limitations. You can't lay cable for like 1,000 miles. It's very expensive to do. So if you have a big network that's far flung over a gigantic geographical area, radio may be your only option. And of course, it's easy to add, remove, and repair nodes without affecting the entire network. And again, another advantage is that we can have any kind of communication structure going on between our nodes that we can dream up. We're not limited by the physical design of the network in our communication strategies. The disadvantages of the radio network is that it's extremely vulnerable, perhaps more so than all wired networks, to hackers and radio frequency interference. And it would be possible to have a total system failure from both natural or man-made causes. For example, an EMP pulse in warfare would bring down an entire radio network. Okay, there are plenty of examples of that in the science fiction movies, where all the drones, all you do is some radio jamming and all the drones cease to be able to operate from their control center. Let's look at network components. Nothing causes people more confusion than all the jargon that goes on in networking. We have hubs, switches, repeaters, bridges, routers, gateway. Total confusion. Nobody really understands it. We're about to help you to understand it a little better. Let's take a hub. A hub is simply a dumb animal. Think of it as the bus for your internal computer network. Whatever it receives on one port, it sends out to all the other ports. Nothing more. Simple, Easy stuff. A switch now, on the other hand, optimizes the traffic or flow of information through all the ports by actively communicating ports instantaneously. It knows by looking at the addresses where the communication is going on, and it connects those two ports together and optimizes the flow of information between ports that are actually doing active communication. What is a repeater? A repeater is simply another ignorant animal. A repeater simply regenerates the electrical signal and makes it stronger. It doesn't affect the information in any way at all. Radio repeaters may change the frequency, but whatever information is being transferred will remain the same. The bridge connects similar networks, but just like a bridge in real life, it filters what goes across it. We have a guard at either end of the bridge, so that only those that need to cross, those messages that need to cross, will go from one network to the other. It does this by looking at the addresses of the messages on both sides, and if they need to get to the other side, then we let them through. Finally, we look at the router. Well, actually, we have another one to go, but the router is higher than the bridge. It has more authority because it operates in the network layer, whereas the bridge is down in the data link layer of the OSI model. We'll cover this OSI model in another video, but right now, think of that as a more authoritative thing because it routes whole packets between networks using the same protocols. Okay? So the packets are bigger than just the individual messages, and it's a router, so it routes your mail between your networks. It can be one or more networks, but they're basically using the same type of protocol or addressing system. Finally, we get to the gateway, which connects totally alien, different networks using completely different addressing schemes and everything. It has to have the ability to convert and translate between different protocols. Haven't you watched your science fiction movies? You have a gateway to another dimension. So watch some more Star Trek, Star Wars, or Stargate, and enjoy the balance of your night. Thank you for watching the Stephen Mendes channel, and we'll see you in the next video.